Pipe sizing by the longest length method, episode 5 of the gas service animated series. Before a flame ever lights, the pipe decides whether every appliance can breathe. If a house line is too small, pressure sags along its length whenever everything fires at once. The appliance closest to the meter may run fine, while the furnace at the far end of the run starves at high fire. Pipe sizing exists so the farthest appliance still gets full pressure on the coldest day of the year. First, every appliance load becomes a flow. Natural gas delivers roughly 1,000 BTU for every cubic foot, so dividing the nameplate rating by 1,000 gives cubic feet per hour. It is an approximation, but it is the one the sizing tables are built around. Our example house has a furnace at 140,000, a water heater at 40,000, a dryer at 35,000, and a range at 70,000. That totals 285,000 BTU per hour, about 285 cubic feet per hour. Now map the system. From the meter, it is 20 feet to TA and 10 feet up from A to the furnace. 20 more feet reach TB, 5 feet drop to the water heater, 15 feet reach TC, 5 feet drop to the dryer, and 10 feet finish at the range. The longest path runs from the meter through A, B, and C to the range. 20 plus 20 plus 15 plus 10 is 65 feet. The tables have no 65-foot row, so we round up to the 70-foot row, always up to the longer row, never down. Here is the heart of the method. That one 70-foot row now sizes every section in the house, even the short ones. On the 70-foot row of the schedule, 40 table for natural gas, half-inch pipe carries 60 cubic feet per hour. 3/4 inch carries 126. 1 inch carries 237, and 1.25 carries 486. For each section, we ask one question. What is the smallest size whose capacity meets or beats the load? The meter run carries 285, so watch it scan the row until it finds 1.25. Work the sections always on the 70-foot row. The meter run carries the whole house, 285, so it takes 1.25. The furnace branch carries 140. 3/4 inch only offers 126 on this row, so it fails. And the furnace branch takes 1 inch. Section A to B carries everything past the furnace, 145, also 1 inch. The water heater branch carries 40, ½ inch. B to C carries 105, 3/4. The dryer takes ½ inch and the range takes 3/4. 7 sections, 1 row, 1 rule. One preview before we move on. The code also allows the branch length method, which sizes each branch by its own distance back to the meter. The furnace branch sits only 30 feet out, 20 feet to T, A plus 10 feet up. On the 30-foot row, 3/4 inch pipe carries 199 cubic feet per hour, more than the 140 the furnace needs. So by that method, the same branch legitimately drops to 3/4 inch. Both answers are code compliant. What matters is that you pick one method, apply it consistently, and document which one you used. 3 traps catch people on exams and in the field. First, rounding down. A 65-foot run is not a 60-foot job. The row must be as long as or longer than the run. Second, mixing table families. Propane tables, different pressure drops, and tubing tables all give different numbers. So the whole job must come from the one table that matches the gas, the pressure, and the material. Third, sizing only for today. The code expects the system to account for appliances planned for the future. On the job, the sizing sheet gets verified. Confirm every nameplate rating and the total connected load. Measure the actual longest run with a reasonable allowance for fittings. Check that one method and one table were used throughout, and that the meter and regulator can deliver the total. And every final answer defers to the current code tables, the manufacturer, the authority having jurisdiction, and your company's procedures. Total the load, find the longest run, round up, and let one row size every section. The printable study sheets in this series walk this exact example on paper, section by section. Next episode, leak investigation and the combustible gas indicator.